Hello, everyone. Hope you're doing well. Welcome to our panel after a bit break in the summer, AI Revolution and Ethics Quest Across Disciplines. I'm Ishita and I'm so delighted to have you all here today. Today we have an interesting topic, AI and agriculture. Agriculture has always been at the heart of human progress, and now AI is reshaping how we grow food, care for animals, and manage our planet's resources. From precision farming to climate smart practices, AI is changing the way we think about food systems and sustainability. So today we're joined by two amazing panelists who will bring a rare mix of perspectives. Dr. Edgar Lobaton, a leading researcher in AI and agriculture at NC State, and his former PhD student, Dr. Silva, now a senior computer vision engineer at Targan, a pioneering industry solutions for agriculture company. So, to break today's session down, our discussion will focus on four key areas. First one being precision farming and yield prediction. So, how AI is being used and how Internet of Technologies, Internet of Things, and computer vision are being used to optimize livestock and prediction for agriculture. Then the next one we have is sustainability and climate resilience, how we're thinking about building climate smart technologies, data driven systems through the use of AI. And then the third one we have is ethics equity, since that is the core of our panel series. So ensuring how AI in agriculture is fair, transparent, and trustworthy. And lastly, bringing it all together, since we have one panelist from the industry and one from academia, seeing how academic breakthroughs can be scaled into real world solutions. So let's get started. We have Dr. Lobaton here. So let's talk about a bit of your work since you're leading the active robotic sensing laboratory at NC State. Your work spans, everything from soybean wilt detection to sweet potato yield prediction using robots, computer vision. So, how do you see AI changing the day-to-day work of farmers? And more importantly, what excites you the most about these applications?
Thank you very much for the introduction, Ishita, and it's a pleasure to be part of this panel. As you mentioned, I'm a professor at NC State and the Electrical and Computer Engineering Department. And a lot of the work that we have done in the lab has been integrating AI technologies into different type of use cases. In particular, in this case, we're talking about agricultural use cases, mainly talking about crop science, plant science type of use cases. We work on things from the larger scale, for example, phenotyping of entire plants, using 2D imaging and 3D imaging, to kind of the microscopic scale when we're talking about identifying things like nematodes, for example, or being able to look at things like cotton fibers and so on and so forth. And then the entire range, looking at produce like, for example, looking at the quality of potatoes, but also looking at quality of other things like blueberries and so on and so forth. But yeah, like in terms of how we see basically AI playing a role in all of these, we see it basically as a tool, as an enabling technology. And I think one of the comparisons that we like to make, I personally like to make as well too, is basically how calculators at some point, became basically this new tool for engineers and pretty much everyone, right? So also nowadays we have things like cell phones, right? So our cell phones basically have become this technology that has been integrated in our day-to-day life. And we are able to use it basically for all these different applications. There's apps that we construct from that as well too. So I think AI in that sense is going to be also be integrated within our lives. The best type of technology is the one that we don't even notice that is there. So I think that's basically where we're heading towards, right? Like a lot of this AI will be integrating a lot of different aspects of our life, and it is right now. For example, even from recommendations systems for shopping, for watching movies, and all of that. And basically, the question is, how do we translate that to the farmer, right? And yeah, so I think that that'll be part of the big impact. It'll be a support system for decisions, and it can help basically monitor larger scale type of settings. It will provide all these tools as well too, and then we're trying to figure out basically how we make those things accessible to different stakeholders.
Awesome. Thank you so much for that. That's really exciting. And now we transition to Dr. Silva, who has previously worked with you and now applying his knowledge at Targan. So, Dr. Silva, at Targan, you've applied AI for poultry welfare, production efficiency, reducing run times and scaling these computer vision systems for agriculture in that space. So, how do you see these innovations translate into actual practical, tangible benefits for farmers and the broader food supply chain?
Hello, everyone. Thank you for the invite of being here. I'm honored to be here back with the NC State community. I'm really happy to be back. So I think I'll start saying what is the company's mission in the market, the mission that we were conceived for, which is basically to help feed the world, provide world-class service to the farmers, and promote welfare to the animals that are going through those systems. So basically, there's three key points: help feed the world, help for the farmers, welfare for the animals involved. And we're trying to do that through two systems at the moment. One is called WingScan, which is a system with a machine designed to separate the chicks by their sexes. So the machine is developed so that while going through the machine, the bird doesn't suffer. And so it's a welfare that we promote there compared to all other machines that we have in the market. And basically what the AI role is in there, the birds go through, actually, let me share my screen here because I have a short video about how the system operates. While I speak. So this is the wing scan system. So you see it's a conveyor belt. So the birds go through there and it goes through a vision system where we pick up the patterns on the wings. And from that, we can determine if it's a male or a female. So that's the main product that we have. But we have also a vaccine delivery system, which is not being shown here in the screen. Currently, how chicks are vaccinated, and we're talking about little chicks, the day of hatch chicks. So you always see us working with little chicks like that. So they're very, very cute data set that we have to work with. So for the vaccination part of it, we have currently in the industry, they come in containers of hundreds in a conveyor belt as well, and they're sprayed over. So this is one type of vaccine, the most common one for after the hatching, right? The problem there is that you're spraying over the bird, and whatever spray that goes on the bird may not necessarily go into their organism. So the absorption is relatively low. And we're developing a system to do individualized delivery of the vaccine. The vaccine will be the same. Again, it's a spray, but we're going chick by chick. And again, they're going through a conveyor belt system that will be equipped with a vision system. And then this vision system is picking up the 3D location of the bird and aiming the face where the head of the spray will promote a higher absorption. The benefit for farmers is immediately the yield that comes from that. So if you're able to separate chicks by sexes, you're able to provide an optimal ratio of food for males and females. So you save on food consumption by the chickens, which is the largest expense when developing chicks. So you have the yield there from the sexing part. From the vaccination part, if they get less sick during their development, they will grow more, and again, promoting more yield to the farmer. So these will be the initial benefits. But beyond that, we have all the effects in the supply chain that comes from these new technologies being introduced in the market, because many of those things are being applied in this industry for the first time. So that opens the door for other tech industries to also chime in and promoting and helping boost those supply chains even more, create more jobs, and allow other technologies that are not applied in agriculture or with livestock to also come in and help promote even more yield and more food accessible to more people. So that's what excites me to work there.
Wow, that's really insightful. And seeing it translate into actual benefit for farmers and improving their efficiency and optimizing their food consumption even for the animals, I think that's a big thing that you don't really see it immediately, but thanks for bringing that up. And there's just so many factors involved, but it's really nice to see you're able to touch different aspects of the industry through your work. So, moving on to talking a little bit about the climate resilience point that we had mentioned, um, one of the biggest challenges agriculture faces inevitably is climate change. And there's a lot of applications that the active robotic sensing laboratory also works on. So, Dr. Louboutin, your research looks at, AI in multiple different application areas from tide predictions to plant resilience. You're also working with the Plant Sciences Initiative, the NC Plant Sciences Initiative. So, how, through your perspective, how can you see AI help building these systems over the long term to adapt to climate uncertainty?
Thank you. That's a very good question, and a very important one, as you mentioned, right? Because there's so much uncertainty about what's happening with the climate nowadays, and yeah, and I think it's also a very challenging task for AI. AI usually works by looking at the existing patterns, for example, historical records on weather, to be able to basically predict what's going to happen. Once we see things that are actually changing, where we're having more of these extreme weather situations and things like that, then that becomes a little bit more challenging for standard AI tools to be able to do that. And those are some of the things that we're looking into basically as part of the research, is trying to develop more robust type of AI models that are much better to predict these things, even though we are seeing kind of changing trends over time. And yeah, so some of the things that we've been working on, for example, is also looking at flood prediction. It was mostly from urban type of applications, but some of the same technologies can be applied to the type of things that we're looking at in here too. So if we're trying to quantify the amount of precipitation, basically that we would expect over the season or quarterly over a month or so on and so forth, then that information can certainly guide the farmers to be able to make some decisions, right, about what we're trying to do. And together with that, we've been working with crop scientists to try to identify basically specific species of plants, some variants that can actually be more robust to the type of extreme weather conditions that we're looking at as well too. So I think AI can help in those things, kind of predicting, so you can figure out how to prepare yourself better for this kind of extreme weathers. And the other portion of it is also trying to help basically identify more robust variants of different plants to be able to get to be less susceptible to this type of extremes. Right? So those are the main applications that we'll be looking at.
Yeah, that is really insightful looking at it, and especially you working with domain experts in the field, like crop scientists. I think that really shows that these aren't challenges that we can just solve with better tech, but more so these are like abstract problems which need very much real world input through communities, farmers, food systems. So that is really
Right.
cool. So, what is one of your favorite projects that you're currently working on amongst all the other climate, not just climate, like agriculture focused projects? I know you have some blueberry projects going on as well. So, can you tell a bit about your favorite one?
Yes, yes. It's kind of a hard question. It's like asking what's your favorite child, right? So, so each project I think brings something a little bit different. But I think one of the projects that we've been a little bit more excited about recently, because mainly the impact that it brings as well too, is this system that we're trying to build, which incorporates standard AI, like computer vision type of techniques, and also some robotics as well too. Trying to identify and track nematodes in soil samples, right? And for that, we're, for example, working with the North Carolina Department of Agriculture. And the way, basically part of the challenge in this particular use case is that NCDA has some central locations, some central labs where basically all the samples that are produced in a regional area get sent to that particular location. And then there's technicians that are going through some of these samples, preparing them, separating the soil basically from the nematodes, and then they have to manually go through each one of the samples under the microscope and identify the species and count how many they have, right, to determine if there's anything that is going to be harmful for the particular crop they're looking at. So that, of course, is a tedious task, takes a lot of time. Also, it's very taxing to the people that are actually doing the work, right? Because they need to be sitting in front of the microscope all day long, basically just going through those. So there's a lot of turnaround even for the technicians themselves. So what we're trying to do is we're trying to automate that pipeline. Part of it is creating the AI systems to be able to do that, but it's not just create an AI and then you're done. Some people may think that that's basically how it works, but it's really trying to figure out how do we integrate it with the existing pipelines, the human pipelines, and also how do we make it as user-friendly as possible, right? So those are some of the challenges there. So in that respect, for example, we started by making sure that we don't interrupt the existing pipelines of the technicians as they're collecting their data. We're using kind of that data to start creating an AI system, and now we're trying to figure out where we integrate it in the pipeline. Our end goal is to have a system that is basically autonomous, at least on the data collection portion of it. So it controls the microscope to be able to collect all the data that you need. And then it can do some of the detections, but it still includes the technicians in the loop whenever the model cannot predict things robustly. And that's one of the things that we're working on. And what that would enable, of course, is that right now, for example, the turnaround for some of these samples can be several weeks, even in the order of 10 weeks or so, to be able to hear back from that, from the moment that you send the samples and they receive it. So we're hoping that we can turn it down into like something in the order of 2 to 4 weeks at the most for people, so they can actually make decisions based on what is actually present in their soils, right? So.
Wow, wonderful to hear that you have like clear, precise, tangible impact, like the time saved and everything, because we need more of this side of AI to be seen. There's a lot of discussion and discourse on social media and all platforms about how AI is going to displace workforce and all these kind of discussions, but these are like real applications where it's much needed. So it's really nice to see your work in that space. So transitioning on to from the academia to the industry side of things, Dr. Silva, from your perspective, being part of both academia and industry, I'm curious to hear about your experiences, like working on these kind of projects, but also your overarching view on how AI could be seen as supporting not just productivity in the agriculture space, but also overall sustainability and animal welfare.
Sure. And yeah, from our perspective here, the systems that we develop as a whole, they will be contributing to the animal welfare and the farmers and their businesses. And as I mentioned briefly before, so when we develop our machines, we have in mind the bird stress that will happen going through the machine, and we try to minimize that as much as possible. For example, on the video that I showed you, you saw the birds going from conveyor belt to conveyor belt. And you minimize the stress there, but minimizing the distance between the belts. So that is pretty much a smooth transition so they don't feel the impact of dropping. And that's something that unfortunately is not yet widespread in the industry. So we are one of the first ones kind of having that concept out there. And that really helps to promote the idea of animal welfare. The AI component is just one part of it. It's like it has to come from the company as a whole, as a mentality. So that reflects on the products that the company is developing, right? And in terms of the AI, it makes possible to make the separation, for example, the wing scan, that the countries and places that used to do the separation of chicks, they would do by hand. So they'll have like an army of people grabbing the birds, looking at the wings, and then separating. Not all countries do that. The United States does it. Some other countries in South America do it. And then the AI can automate that. In the US, we have a special problem that we cannot find labor to do that. So the farmers ended up receiving the hit of not having the labor available, and that may increase food prices. And if food prices increase, less people will have access to quality meat as chicken. So I think, at least for me, coming into this company, it was motivating to see that if we do well our job, we'll be able to feed more people because we'll make food more available for more people and help fight hunger. And again, as I mentioned before, all these technologies are well known in other domains like surveillance, like social media, and many other domains. But with livestock, we're one of the first ones. So we have to break a lot of barriers. And by breaking those barriers, other players will be able to come in and kind of be a trickle down effect, a domino effect of more technology and more value and uh, uh, less cost for the product for the consumer at the end of the line, helping promote a more food for more and more people.
Wow, lovely. It's so inspiring to hear that in this phase of uncertainty, there's room for innovation and hope. And I love that, you're encouraging through your company that, we work not in silos, but in collaboration. And I think such systems can help us kind of expedite that process of connecting these real world applications to the day-to-day work that we are all involved in. So it's not just a tool for efficiency that I hear, but a partner in resilience, like helping come bring all of us on the same page about climate change. So really insightful. Now I want to change gears again on our third topic of discussion, which is the ethics aspect of it, which is at the heart of our panel. And the ethics, equity, and adoption, that is pretty much what is the need of the hour in kind of standardizing across different industries using AI. So, of course, we're aware that with technology comes big responsibility, and then AI obviously has kind of elevated the responsibility. So AI in agriculture also raises questions about equity, access, and trust. So Dr. Lobaton, through your work and experience, how do you put forth, like how do we ensure these powerful tools not just benefit, not just benefit these large agriculture businesses, but small, mid-sized farmers, small businesses in especially growing regions like North Carolina or the South in America, or even just around rural parts of the world.
Yes, also a very good question, definitely. Yeah, and I think these are, let me give you two different perspectives on this. One of the perspectives is going to come from just purely how we're making AI accessible, right? And one aspect of it is also coming from the government that we are trying to kind of democratize the access to AI in some sort of way, right? And it's for education, but also for research purposes, right? So, but at some point, basically, we start developing all these AI models and all these different things, right? All these different tools, and only people with a specialized hardware was able to actually use it, right? Then some companies actually starting to take some initiative, for example, Google, making some resources available like Google Colab, where people could actually use some GPUs for free for these purposes. And now what we're seeing is that basically the government is kind of catching up with some of these tools as well too, and they're making some GPUs, graphical processing units, and hardware, specialized hardware, accessible to for education purposes and also for research purposes as well too. So I think these are the type of things that we're seeing now at this stage on education and research, and I think some of this is also going to come down to the agricultural side. I know the USDA is kind of planning to do some expansion on the compute capabilities as well too, with some similar intent as well too. And the idea is that some of these will become available to just regular people as well too. Agriculture applications would be definitely part of that as well too. Even at NC State, we have some programs where we're trying to kind of support some of these AI models and how do we make them accessible via web portals, web cloud deployments, and so on and so forth. One aspect of it, more generally and broadly speaking about AI, how we're trying to make it more accessible to everyone. The other aspect of it is basically that AI, as I mentioned, is a portion of it, like the programming side of things, the software that we're building. But the other aspect of it is the robotic or the hardware component, right? So And for example, on places, states where we have like these huge kind of like farms, right? Like then at that point, some larger type of equipment, robotic equipment or automated type of equipment have been used now for several decades, let's put it that way. But at this point, what we're seeing is that we're starting to see more of a transition towards smaller robotic systems and different type of monitoring systems that can actually help not only the large farms, but also the medium-sized or smaller farmers, as you said, here. Because that's very common, for example, in a state like ours in North Carolina. So we're trying to build basically systems that are a lot more accessible to people. We're seeing a lot of kind of DIY kind of stuff where people start building their own systems and then kind of connected to AI systems. And a lot of these tools are becoming available. And I think like the question at that point becomes more of an access question right now that the resources are available. How do we ensure that people can actually use them? Right. And that's where, for example, NC State is working with the extension farmers to be able to provide basically a transition, a bridge, right, to make people aware of the tools that are becoming available, and then potentially provide training for people to start using those tools as well. So that's kind of our internal roadmap in some ways to hopefully make AI and more of that robotic technology accessible to everyone.
Yeah, wonderful to see different efforts across board. And I think definitely a lot of these regulations, rules have been actively developing. So hopefully we can meet the customer, meet the needs at the point where they are already able to access similar products and goods. So it's not that they have to go out of the way, but we meet them at their level. Very insightful. And on the other hand of industry, at Targan, Dr. Silva, you're deploying AI systems in the real world settings. I'm sure you get to interact with these farmers at different levels within the company, more on-site testings possible. So how do you think about farmer trust? How do you think about that ethical data use for those specific farmers, since they are not necessarily all of them are technically literate in these aspects, especially in this ever-evolving AI world. It's very hard to be very equipped with that exact knowledge of what is within my rights, within the state rights. So I guess one question is, how do you think about these farmer trust kind of themes, and also in general responsible adoption when building products like these at scale?
Right, it's a very good question. Um, and very important for the farmers, especially now that we are at the point of introducing devices that will collect data continuously in order to take those automated decisions to promote all the benefits that we expect from them, right? So, and with the system that we have there, one may think, okay, so we always talk about security and confidence of data when we're speaking about human beings, right? But in that domain is also important because we are continuously taking pictures of the little chicks, and by the shape and the format of the chicks, you can trace them. That you may be able to trace them back to the phenotyping that was developed for raising those chicks. And at that point, we're exposing some secret of the hatchery itself, some industry secret that they may have. So protecting that data is crucial to their business survival, really. So in our case, our system is all pipelined with technologies that are already available and reliable for the securities that they provide and the deployment capabilities that they provide. So we rely on companies like Microsoft or Amazon that they already known and have system already in place for taking the data in, deploying them securely, keeping them safely as well. We don't do anything from scratch in that regards. We just rely on the industry players that are already known for that type of technology, and we plug them into our solutions and use them to actually deploy our technology at scale.
Wow, that's a really good answer, and thank you for highlighting that view. It doesn't, come across when you think about it, but at the end of the day, we need this technology to be beneficial to farmers and not harm their existing
Yes.
efforts. So it's not just more about giving better predictions, giving better optimization, but also kind of keeping their safety and dignity of their work at heart. So very insightful. These things that you
And
don't see. Mhm.
oh, just to add, one thing I forgot to mention too, other than the machine that is there, we as a company, we cannot share the clients that we have or locations because everything can be traced down to, okay, so you, you don't have as many hatcheries in a certain radius, right? So you say a
Mhm.
certain city, you know, okay, it's probably that hatchery and that may trace them down to, okay, so they're using this technology, so they're able to do this and that, so that immediately make them vulnerable. So the protection in order to make farmers more open to the idea is very, very important.
Right. Yeah, these things you don't really hear so much outside of the, company and media. So really thankful for you to share that.
Sure.
And could you share a bit about like what is the scope that they're focusing on? Like which part of America you are focusing on?
It's pretty much everyone that is open to that technology. There are still farmers that are not open to the sexing yet.
Mhm.
There are countries that they don't do because of labor, and they're seeing a possibility now of having that automated. So it's basically being a little bit of word of mouth, and they talk between them as well, the hatchery. So we get
Mm-hmm.
contacted in that network as well, but it's pretty much anyone that is willing to do the sexing of chicks, and it's not all types of chicks that are sexable. There are breeds specific for that. So if a hatchery is working with that type of breed, they can use those machines or that labor. It could either be people or the machine, because it's not all type of chicks that we can sex by the wing pattern.
Right. And so
Mhm.
this is like the main project that you are focusing on. Um,
Yeah,
like,
that's the main driver of the company right now.
right.
I don't work on that project. I work in the vaccination project, and that's under development, and we're
I,
currently testing it. Um, and but still, we have to prove a lot of metrics to
mhm.
show that, okay, vaccinating in this way will be able to increment the food conversion ratio that I mentioned before,
Mhm.
and we're very close to that. And yeah, with that, we will be able to make it commercial.
Right. Very informative. Thank you so much for sharing that. Now, talking a bit about both of your views, since we have interesting mix here. So this panel was really unique, and I was really glad because we have a professor and his former PhD student. So really nice to see. So both of your views might stem from the same root of thinking, but interesting to see how they have been developed, especially for you, Dr. Silva, since you've been working for these many years. But Dr. Lobaton, to start with you, what do you see as the biggest opportunity for collaboration between academia and the agriculture industry that's working on advancing AI?
Uh, yeah, I think there is a lot of opportunities really to collaborate, right? So um, it also depends on the type of industry as well too. Like the collaborations can vary a little bit depending on that. For example, we've seen collaborations with larger companies, for example, that in which they may have enough resources to have almost like their own kind of like research branch, right? That they're doing their research. They hire scientists like Rafael in here to kind of do some of their own research, right? And maybe that's their focus as well too. And then what they may be more interested in is on having kind of some collaborations about engaging or recruiting, I guess, students, right, or scientists for the different type of research as well. So it could be through kind of consulting of the faculty or just actually hiring the graduates that we have. So that's one opportunity. The other opportunity, which is maybe more for like smaller companies as well, is that there's a lot of technology that NC State is developing, and we see basically that a lot of that innovation could translate into things like startup companies, for example, or small kind of licensing opportunities for companies to kind of at that point partner up with NC State to be able to kind of expand on those things. And the other thing is that sometimes they may need some help developing some sort of technologies, and maybe in particular it may be more of a proof of concept on the earliest stages of a startup. So NC State can actually help people out with that. We partner up with companies quite often, for these different type of use cases. So I think those are kind of the opportunities, kind of developing the technology or providing kind of the manpower in some sense, for the larger companies once things are a little bit more mature.
Yeah, really nice to hear that. And then, Dr. Silva, what do you need most from academia or the academic research to accelerate what you're currently doing and innovating to keep at this pace or even expedite that to responsibly innovate?
Well, I think what is very beneficial in academia, I think that academia has more freedom to develop a certain idea or engage in a certain project, while in a business, we are trying to develop or solve a specific problem. And I think the way the academia can contribute to industry in that way is really comes from the for the freedom to the for to the extent that it exists there for doing research in many different areas. For example, here at Targan, we cannot develop helicopters because we are chick business. So that's what we do. We will expand to other type of animals, but we don't do much beyond that because as a business, it doesn't make sense to be super broad. We want to be very good in what we do. And academia doesn't have that concern or that constraint. It has the freedom to tackle any problems that are within the society or within the industry. And I think that's really where most of the benefit will come. And as Dr. Lobaton also mentioned, not only through the research, but also through the researchers that the academia develop and provides to the industry and to the own academic community as well. So I think this model ended up benefiting a lot industry. But in terms of, in order to be more focused, I would say that forming researchers that are really ready to not only work with abstract and theoretical aspects, but also being able to translate them well to not only industry needs, but any open problem that may become a driver for a new startup to come up, right? And I think NC State does a really good job in doing that because I think our education goes really towards practical problems, think and do, right? And I think that's really the direction we should go, and academia would contribute and continue contributing a lot to industry and the society as a whole.
Yeah, very well said. Really, really nice to hear your thoughts. And now I'm really interested in knowing both of your views about the kind of trajectory that we would see in this space after a few years. So, we've talked about AI as a tool, AI as a tool for sustainability, ethics, collaboration, different domains within sustainability agriculture. So, looking ahead, if we are on the same trajectory, or even, we expedite the trajectory and we're, working together in these human-centered systems more collaboratively, where do both of you see AI having the most transformative impact on agriculture in the next 10 years? You might have been asked this question before, but I'm really curious to see your thoughts on this. So, anyone could go first.
Dr. Lobaton, please.
I was about to hand it to you. Yes. Well, yeah. So I think, yeah, speaking broadly about AI first, we're seeing a broad integration of AI in a lot of different areas, right? And I think that technologies are being developed quickly, and we have a lot of technology that actually is ready to be applied to agriculture, but it hasn't made its way there, right? And part of it is that there's some barriers, and some of the barrier that maybe kind of talking a little bit about that too is that we need is to overcome in some ways is how do we take advantage of all the data that is available out there, right? And a big concern, of course, is having proprietary information and all of that, right? But there's new approaches coming from AI that are kind of making sure that some of these aspects of releasing or sharing kind of like some sensitive information is kind of handled in a meaningful way, right? Like very carefully. So, for example, like federated learning type of approaches and things of that sort. So there's approaches like that. Of course, we need to figure out how do we properly integrate it into this framework so we can start developing a bunch of more robustly these AI models in a way that are going to generalize better and they're going to be more applicable to a lot of different domains. Right? So the other aspect, the other challenge is basically how do we make this tool useful in some ways to the researchers, but also like the farmers at the end of the day, right? So how do we make them accessible, and then how do we kind of go beyond that barrier of just having kind of a cool app into something that is actually useful for them, right? And part of it is that because there's so much development out there, it's kind of hard to tell what is the right type of AI, right? What's the AI that is actually really something that you can rely on, and not just something that somebody just developed, that at their own kind of like computer home or something like that, right? So I think that needs to be in some ways standardized. So there needs to be some kind of like government kind of regulations that need to happen. Uh, and that's specifically more important for things like agriculture, right? Because of the target population that we're talking about, right? So if we're talking about something like a recommendation system for like a movie subscription program, Netflix, Hulu, whatever you call it, then basically the mechanisms are already kind of built into it, right? Like if something doesn't work, then you just don't like the service and then you just don't pay for it, right? So, and then that's basically how it works. But in the case of agriculture, what's happening is that these AI systems are integral for the livelihood of people, right? Like, it's not necessarily a life or death right away because of a medical type of situation, but the income of people like are at the line, right? Like at this point, right? Like the survival of a farm could be at the line, whether they're using the right type of AI system for this, right? So I think because of that, there needs to be a substantial type of regulation in terms of how we use these type of AIs and making sure that they are the right type of AIs for the different type of use cases at that point. So given that we overcome kind of these challenges, which I think are the kind of the main barriers at this point, we're going to see basically how AI can be integrated in all these different domains, right? I can imagine it that it's going to be more of a standard kind of decision system, right? It could integrate with the existing systems that people may have in place in the farmer, at their farms. It could be new systems that people start building. It should be kind of relatively kind of democratized in some sort of way, and that's what I'm saying. So things where I think you're going to see a lot of impact in general, of course, is that, and we're seeing this for AI and robotics and automation kind of in general, is that things are kind of repetitive, right? That take a lot of time. And don't necessarily require, or may require some expertise, right? But not necessarily like new knowledge that needs to be generated all the time. And those are things that where AI can actually help out for this type of application. So, I discussed basically this new method of kind of detection type of projects, for example, right? And these type of things. So I think there's a lot of opportunities for things like that to be automated where AI can actually help for farmers. And the idea, as you mentioned, maybe like from the very beginning, is that there's kind of this sense, a little bit of a fear, right, that AI is going to take over all these jobs. And kind of going back to how I started kind of the discussion is that AI, more than anything, is a tool, right? So, again, that's how we try to think of it as well too, because we have seen this type of developments throughout history multiple times, right? Like it happens when industrialization came, right? Like it happened. I was giving the example of the calculator or the cell phones as well too. So that means that things are going to transform and they're continuously changing. So, of course, some things are not going to be needed anymore. We don't see people with abacus, like trying to do additions and all of that. We have calculators, we have cell phones to be able to do all these things, right? Computer systems to do all these things. But that means that it's going to be giving opportunities for new things, right? And what's going to happen is that people, of course, are going to need to have that access to that and also need to have a little bit of training to be able to use those technologies. But those are kind of in general the changes that I'm seeing.
Yeah, I think thinking about like the roadmap for 10 years from now, with this technologies being introduced at industry, um, some things that I see are they're very positive. Or for example, in academia, especially at in-state, I've seen a continuous focus on agriculture or precision agriculture initiatives. Like we had the plant sciences building being finished very recently, and a lot of good initiatives coming out of that. And with those initiatives, we'll have more professionals being formed, we'll have more research being developed. And from that, again, a trickle down effect for new startups to come up with new ideas and new products and helping the lives of people and farmers. And I think initiatives like this to focus and have more investment on initiatives related to precision agriculture, especially to help farmers overcome some maybe preconcepts that they had about the technology and really see the benefits in the medium to long run are very important. And I think a lot of unpredictable innovations will happen only by these initiatives. But I more of an optimistic person, and I think most of the things that will come from initiatives like the ones we see not only at state but several universities here in the country uh, adding more focus to the precision agriculture realm, I think will bring a lot of benefits to the consumer at the end of line that will be able to get more quality food, paying less, and fighting hunger, which is all the most important.
Yeah, I really love these thoughts because I think at the core of both of your points is the human-centered aspect of this application. Like as you mentioned, Dr. Louboutin, there's so many other applications of AI and recommendation systems and everything that touches us in day-to-day life. But something so integral like the safety of our farmers, the safety of our food, the protection of the yield and the crops, and then the animals involved, I think that's a different dimension of AI application than just the day-to-day we see. And I like that you both didn't, although you're both from like a technical background, you didn't assert that AI is end all be all. You asserted that it's more of a tool. It's something that's going to augment our current processes, and it's going to kind of redefine and kind of elevate our standards of care, but not that it's going to change the world, not adding to the hype that we see in social media at all. And I really like that view. And I wasn't really informed so much about the agriculture space before this conversation, and even the opportunities, the challenges. So I really appreciate both of you sharing a lot about your work. And if you have any questions in the chat, if you have any questions from the audience, feel free to like put it in the Q&A box or the chat. And we definitely plan to release this video. So if you have any questions, post that. Please email it to us so we can get you the responses. But overall, this has been a really insightful conversation. So what are both of yours like immediate next steps? Like how, like in a day in your life, like what are some things that you immediately like working on in this space that you would want to share? Um, could be minute or anything major, like a grant, which is pretty common, I hear. So
Yeah, from our end, as I said, we want to have this vaccine delivery system out in the industry as soon as possible. That's what we're working hard towards. And we'll have initiatives with working with swine and fish soon. So that's exciting. We want to promote the same mindset that we've been developing with little chicks when I go to other types of animals as well.
that's amazing.
That's amazing.
Yeah, and I think from our end, of course, they're always working on proposals, but we're always trying to figure out how do we start to make some of these tools accessible to the broader like stakeholders, right? Like either research labs, um, um, extension agents or even the farmers as well too. Right? So before, I think more traditionally, we've been working on things like just proof of concepts, like prototypes of things. But we, as a university, I think we've been a lot more interested in trying to do a lot more deployments. So we have efforts within the university and the Plant Science Initiative at NC State to kind of start pushing those things forward, and that's something that my lab, of course, has been engaged on as well.
Awesome. Thank you so much for sharing, and thank you for both of your time and being so generous with your time and your energy. We really enjoyed this conversation, and we hope to share it with more people since not many could join us today because of other events clashing with this. But yeah, I hope to stay in touch. And if you both have any resources you'd like to share, we have like a post panel email that we send. So we'll send that with the recording as well. But yeah, thank you so much, both of you, and all of you for joining as well. Have a good day.
Thank you.
Thank you so much for organizing. Thank you for the opportunity.
Thank you so much.
Bye, all.